A C program is made of code and data. The code is structured within functions and the data through variables. Variables can be defined inside a function as local or outside a function as global. It's important to remember that variables are only accessible from within the file or function that they're declared. This concept is called scope. Variables are defined using a type, a name, and optionally, a value. Remember from the last tutorial that the first golden rule of programming is that for any information used in a program, create a proper variable for it. Functions are defined using a type and a name, followed by parameters inside a pair of parentheses, and a body of code inside a pair of curly braces. Any line of code that starts with a type is creating something new, be it a variable or a function. The type of a function indicates what sort of data it creates as a result. Another name for this is its return value. A function that returns no result has a type of void. The parentheses hold parameters this function takes to execute its code. Remember that the second golden rule of programming is to always define variables and functions before using them. Every C program must have one and only one function named main, which is the starting point of the program. The third golden rule of programming is that a program is a sequence of instructions. The program execution starts from main and continues sequentially until main ends. Functions are only ever executed if they are called. When a function is called, the CPU will go to its code and follow the instructions until the function ends. Every function can end without getting to the last line by using the return keyword. We'll touch more on functions in the next module. Preprocessor directives are commands to the compiler that are carried out before the code is compiled. Hash include inserts an entire header or source file into the program. Hash define gives a name or label to some text that allows the label to be used in place of that text. When the source file is compiled, the label will be replaced by the text. For instance, hash define num10 would replace the word num with 10 whenever it appears in your program. The benefit of this is that if you have a number that is referenced throughout your code, a number you might want to change later, you simply have to change the value in the hash define. This is a huge time saver if you have 100 lines of code referencing the same value. The fourth golden rule of programming is to use decision-making structures to allow conditional operations. Because a program operates in a linear and sequential fashion by default, it performs exactly the same instructions in exactly the same order each time it's run. To allow our program to be more useful, we can have it make decisions based on the data it processes. This means that it will perform an operation only if certain conditions apply. As an example, we can modify report2 to end when the user enters 0. The keyword we need to use is if. In parentheses, we put the condition or conditions we want to check. If the condition is met, then the following line will run. In this case, if num is equal to 0, we want a return command to execute, terminating the program. If we want to run multiple lines of code, we can use curly braces. It is important to note two things in this example. First, the if statement does not end with a semicolon. Second is the use of the double equals in the condition. Since many new programmers understandably get confused by the single equals versus the double equals, let's quickly differentiate the two. A single equals is the assignment operator. This is used when the programmer wants to set a value. for instance, when initializing a variable. The value of the variable on the left gets replaced by the total value of whatever is on the right. A double equals is the equal to operator. This is used when the programmer wants to make a comparison between two values. If you're writing an if statement, this is the operator you can use in the condition. Don't use the assignment operator because the compiler will not approve. Returning to the if statement, we can add a secondary set of instructions to run if the condition is not true by writing else. Here we want the program to determine if the user has entered an odd or even number. To do that, the statement will be if data modulo 2 equals 0. The modulo operator isn't as scary as it looks. It gives the remainder after a division. So for instance, what's 7 mod 2? Take 7, divide by 2, and whatever's left over is the answer. In this case, 1. So, if the remainder is 0, we know the number's even. Now we need to set a variable we can reference later. Here we'll create a boolean, which can be either true or false. We'll call it odd and set it to false. Now we can continue by typing else odd equals true below that to deal with the other possibility. Now in our second if statement, we print a different message depending on odd. Note that the only condition we have is just the value of odd. When there is no comparison in the condition, the program assumes it needs to check if the condition is true. It's worth bearing in mind that Golden Rule 1 was applied here. We have some data, so we created a variable for it. We have user input, and we know if it's odd or even. Always put your data in a variable. The fifth golden rule of programming is to use iterations, or loops, to perform repetitive operations. One of the main advantages of using computers is their speed when performing many operations. In most cases, these operations are similar. For example, repeating some action on each item in a list of data. Loops are a very useful tool at our disposal. Let's say we want to repeat the previous example 10 times. For this, we would use a for loop. A for loop has 3 parts. First is the creation and initialization of a new variable. This will be our counter for the loop. It is traditionally called I, but like any variable in C, you can name it whatever you like. The second part is the condition of our loop. As long as this condition is met, the loop will run. In our case, we will write I less than 10. Finally, we set the increment that will be applied to the counter at the end of every loop. I++ is simply shorthand for I equals I plus 1. Incidentally, that's where C++ got its name. There's some programmer humor for you. So we have a counter that increases by 1 every time the loop runs. Then at the start of every loop, we check to see if the loop has run fewer than 10 times. If not, we'll end the loop. Just like with if statements, we can run as many lines of code as we like by using curly braces. A second type of loop we can use is the while loop. While loops only have one part, the condition. We can modify our program to end when the user wants it to by using a while loop. We'll create a boolean called end and initialize it to false. Then, as a condition for this loop, we'll write end is equal to false. The program needs to end when the user enters 0, so we'll just need an if statement to check if that's the case. If it is, then we'll set end to be true, and the loop will no longer repeat. But we need to make sure the remaining code doesn't get run. Because the condition is only checked at the beginning of each iteration of the loop, nothing is stopping the program from executing our code one last time. So we'll add an else statement and move our code into some curly braces. Now the code will only run if the user enters a number that is not equal to 0. The act of putting one if statement within another, or of putting loops inside other loops, is called nesting. Sometimes it can be hard to know when to use which kind of loop. The general rule of thumb is to use for loops whenever the program should know exactly how many iterations are needed, or will have some data that tells it how many times it needs to run. One example would be if the user enters a number to tell the program how many times the loop should run. You as the programmer don't know what that number is, but you know that the program will when it's run. In that case, you can use the variable containing this data in the condition of the loop. If you don't know how many iterations will be needed, then you should use a while loop. That said, this is just in general, so it's entirely possible to write something equivalent to a while loop using a for loop, and vice versa. Writing more complicated code requires proper thinking and developing an algorithm first. Consider a simple guessing game. Player 1 picks a number, and player 2 has to guess. After each guess, player 1 hints as to whether the number is higher or lower than the guess. A good practice is to always start by identifying the information the program is processing, and from there, we can determine what the program should do with the information. In this case, we have the answer, which is the number player 1 is thinking of, and player 2's guess. So our algorithm might be something like this. Create and initialize a variable called answer. Create a variable called guess. Then we start a loop. In this loop, we'll get the data for our guess from the user. We'll then compare the guess with the answer and provide a message based on the comparison. Take a look at the sample code for the implementation of this algorithm. Let's look at another example. Let's say we want to find the rightmost digit of a number. Let's say that number is 123. 123 is an integer. It isn't a decimal, so we can take advantage of that. If we divide an integer by 10, it'll lose the rightmost digit. 123 divided by 10 becomes 12. If we multiply that by 10, it becomes 120. If we subtract this number from our original, we're left with 3. By going through this one case, we can find a process that will work for all 3-digit numbers. To do this programmatically, we would start by creating a variable to hold our original number and a variable for each of the digits. So 4 ints total. Our original number variable gets initialized to the user's input. We need a temporary variable to hold our calculation while we're working on it, so let's make one called temp. Now we set temp to be equal to number divided by 10. Digit 1 will be number minus temp times 10. Now we set the number to be equal to temp and repeat the process to find digit 2. We set number to temp again and find the third digit, just like before. Finally, we print the results. Variables and functions in C can be named anything as long as the name follows the following rules. First, the only valid characters are underscore, letters, and numbers. You can't use any special characters other than the underscore. Second, the starting character of a variable can't be a number. It can only be a letter or an underscore. Third, some words are reserved, such as keywords or operations. You cannot name a variable return or exit, for example. Different programmers use different naming conventions to simplify creating and reading code. While it's not necessary to follow these conventions, they can be very helpful. In this course, we'll try to abide by some guidelines that are quite common in the world of software development. First, variable names will start with lowercase letters and functions will start with uppercase letters. The rest of the function can be lowercase. If the name has multiple parts, then we can use an uppercase letter to start the next word, or an underscore. Labels or constants, such as those created using a hash define, should be in all caps. Names for functions and important variables should be meaningful. When naming them, you should err on the side of being overly descriptive. It'll help you in the long run if your code tells you what it does just by looking at the names. Bear in mind, though, that the longer the variable names are, the more unwieldy they are. If you have a counter variable in a for loop, for instance, those can be just I or j. But for something unique or important, longer is better. Finally, global variables are identified by a G underscore at the beginning of their names.